Good afternoon, Professor Herman. My name is Muhammad Finsya Indra with my colleague Esa Gabriel Pratama and Muhammad Nibroos. And today we're going to discussing about humidity sensor. Next. Some industry fields such as food production, air conditioning, meteorology, and agriculture require humidity control in order to maintain the quality of the products. The mechanisms of reading the humidity could be initiated by a variety of measuring methods. The way to calculate humidity could utilizing porous and water absorbing insulators or the electrics, semiconductors that alter impedance due to water's donor properties, solid states conductors or electrolytes, and piezoelectrics that change mechanical wave characteristic due to water absorption. A hygroscopic substance is sometimes used for the electric controllers to calculate the humidity. The hygroscopic substance could be an indicator for humidity sensors due to its characteristics such as changing length when moisture is absorbed or dissolved. Any rapid change is informed for rapid response since sensors detect change practically instantly. The data collected by sensors provides a complete picture of the equipment's usage. As a result, scheduling maintenance and repairs, reducing downtime, avoiding important issues, and maintaining worker safety are all made easier. It also aids in the optimizations of performance and the reduction of waste. Next.
Next is the ceramic components in the device. So the digital humidity sensor looks like a figure on the top left corner. The ceramic components are on the inside. When we look inside the tool, we will see a white rectangle shape, and that is the humidity sensor. If we take a closer look at the humidity sensor, we can see that the white and rectangular shape is a ceramic plate. A more detailed image of the ceramic plate is on the right side of this presentation, where we can see a more detailed version and explanation. The conventional material used for sensing element of the ceramic humidity sensor are metal oxide, spinel, and perovskite type oxide. Next.
And now I'm going to present about the working principle of the humidity sensors. There are two types of ceramic humidity sensors which have obviously two different working principles. The first one is the ionic and the second one is the electronic. Okay, so the ionic type of humidity sensors, it works by the impedance of the sensor element decreases with an increase in the RH or relative humidity due to the physisorption and capillary condensation of water molecules on the surface of the material. RH or relative humidity is in the form of percentage, which is the ratio of the water pressure in saturated pressure or atmosphere. And the second type of sensors is the electronic type. It works by the logarithm of the conductivity of the element changes linearly with the logarithm of the water vapor concentration. Water molecules act as an electron donating gas and their chemisoption increases or decreases the electronic conductivity depending on whether the material is a N or P type semiconductor. Commonly, the sensors work by utilizing the common phenomenon of chemical and physical absorption of water molecules and capillary condensation in the pores of the microstructure of the material.
Next is the crystal structure of the ceramic. So the sensing element of the ceramic humidity sensor varies. Each type of ceramic material has a different structure. As I mentioned before, the conventional material used are metal oxide, spinel, and perovskite type oxides. Uh, while the list below is the more detailed name of the material used for sensing element of ceramic humidity sensor. So for crystal structure number 1 until 6, the principle of this crystal structure is conductivity changed by physical adsorption of water on the porous ceramic surface. And for crystal structure number 7 until 8, the crystal structure works by the conductivity change by chemisorption of ceramic on oxide semiconductor. And for the crystal structure number 9, it works by conductivity change by physical adsorption of water on the porous ALO film. Next, this is the illustrative image of the crystal structure. As we can see that it has a name on the uh, below the image for MgCrO and titanium oxide is on the left top corner, and for the number second, number third, and so on is on the right side, and the top bottom right corner is the number 9, the crystal structure of ALO thin film. Next.
And now I'm going to present about the fabrication techniques of the ceramic humidity sensors. There are three commonly used processes for producing these ceramic humidity sensors, which are conventional ceramic or semiconductor processing, and the second is the thick film, and the last one is the thin film. I'm going to especially detailed about the thick film and the thin film. Okay, so the thick film is generally grouped into two steps. The first one is the screen printing, and the second one or the last is the drying and firing process. Screen printing is considered one of the oldest forms of art reproduction that deposits ink or paste onto a base material through the use of a finely woven screen with an edge pattern of the desired geometry. Screen printing could be seen on the production of t-shirts that have graphics or text on the design. And the second step is about the drying and firing process. This is done due to it removes the remaining organic carrier from the film. It develops the electrical properties of the ceramic humidity sensors, and the last one, it bonds the film to the substrate or the base materials. Then I'm going to presentate about the thin film process. Thin film varies. It generally group into two. The first one is the gas phase, and the second is the liquid phase. There are many different methods used in the gas phase and even in the liquid phase. One in the gas phase there are magnetron sputtering, second is pulse laser deposition, atomic layer deposition, and chemical vapor deposition. On the liquid phase, it could be done by using electrospray deposition, electrochemical deposition, salt gel method, and molecular precursor method.
Okay, so now we're gonna discussing about the possibility of raw material resources in Indonesia, and humidity sensors basically components consist of two main materials. Firstly is perovskite, and second is metal oxide. For the perovskite, could be found in the Earth's mantle and has been mined in Arkansas, the Urals, Switzerland, Sweden, and Germany. Unfortunately, currently there is no data mentioning perovskite raw materials that is located in Indonesia. Meanwhile, for the metal oxide, one of the raw materials for the humidity sensor is metal oxide, including aluminum oxide. Indonesia is known for the mineral resources such as aluminium. The Sumatra is one of the largest aluminum manufacturers. Second is zirconium. Zirconium is also utilized in the making process of humidity sensors. Zirconium sand located in West Kalimantan. While for ferrite or iron, Indonesia has abundant resources of ferrite. There are in Cilacap, Cilegon, Banten, South Kalimantan, Lampung, and Central Sulawesi. Meanwhile, for phosphorus, could be located, could be found in Bogor and Pangandaran. Calcium is extracted from limestone. Limestone mines in Indonesia could be located in West Sumatra, East Java, Central Kalimantan, and East Kalimantan. One of the biggest limestone in Indonesia is in East Java. The exact location is in Tuban. Next. Thank you. That is from all of us. If you have any questions, please kindly message us. Thank you.